Okay, so hello everyone, and welcome to this amazing workshop that we have today. And today we'll be discussing all about Dagger. We'll be doing a hands-on workshop. There is a GitHub repository that just dropped in the private chat, so I'm really excited for that. How it will go. And today I'm joined by Dagger team. So I hopefully you know me. So I am Sayam Pathak, and I'm joined by Solomon Hykes and Kyle from Dagger. Yeah, let's start with a little bit of introduction. Solomon, please go ahead.
Sure, yeah. Thanks so much for having us. So yeah, I'm Solomon. I'm a co-founder of Dagger, and I'll introduce Kyle also. Kyle is our ecosystem engineer. He has more experience using Dagger than pretty much anyone. He's out there building things on Dagger, and he's kind of seen it all. So I'm very reassured that he's here with me. I feel like things will go much smoother. And before Dagger, Kyle was a release engineer at HashiCorp, so he ran those huge CI/CD pipelines that actually shipped all of the HashiCorp software. So he's also coming at it from a perspective of, having felt the CI/CD pain, which is what Dagger solves or tries to solve.
Nice. So we'll not go into one thing, which most people usually go with, you started off with that Docker and then how you pivoted to Dagger and stuff. But we'll start with the crux of it. So we'll start initially with the first discussion point of why Dagger was created in the first place, and like what were the gaps that you saw in the industry when you were talking to people when there, because now it's the time. Docker is there, containers are there, Kubernetes is there, the ecosystem is mature, the cloud native ecosystem is a map that no one remembers by heart. But how exactly you kind of talk to people with their existing infrastructures, existing pipelines, existing code bases, existing everything which is there, CI/CD and CNCF integrations, and what were the missing pieces that you thought you need to create a big thing, the next big thing?
Yeah, so I mean, after leaving Docker, me and my co-founders Sam and Andrea, we took a break because it was 10 crazy years, and then we went back out there and started talking to software teams about the problems they had and how we could solve them. And something that came back a lot was the pipelines that ship the application, right? Build, test, CI, CD, all of that mess. And it turns out it's a mess for everyone, small teams, large teams, it doesn't matter. And you mentioned what's the missing piece. It's more like there were too many pieces and everyone was trying to glue them together using scripts in YAML, basically. So we have these super modern tools for developing, for deploying, for building, but then holding it together is the same duct tape that held it together 40 years ago. It's basically Bash. And then these days it's Bash running in these black box CI servers that you can't run on your laptop, and they're incompatible with each other. So it's just an extra step of complexity. If anytime you want to fix anything in the pipeline, you got to change it locally, then you commit, you push, and then you wait. We call that push and pray. And then if you're lucky, things work, but most of the time you forgot, a tab or something. And then you have to start over. So, we started building something to fix that. So, and that's Dagger. So that's the problem that we saw. Just messy monolithic scripts that glue many, many tools together.
Nice. So when you started to build Dagger, how soon did you reach the kind of initial product, you would say, to release it to public, to test it out? From the ideation phase of identifying the problem to something that people can test.
Oh, it's been a very long process. I mean, we like to ship very quickly and then iterate, but we've been shipping quickly and iterating for almost 4 years now. And the first 2 years was mostly just, tinkering, just random prototypes, talking to people. And then eventually we sort of started getting closer to a design that made sense, and then we launched it about 2 years ago. And then we kept iterating and launched a major update to the platform a year ago, and then most recently, 3 weeks ago, we launched another set of features to complete the platform. So we're always iterating, we're always shipping, and we're always doing it with users telling us what they like, what they don't like, and then we just keep moving. That's the most important part.
So when you say users, these are the people, the initial set of people that you have started working with, or these are the actual customers that you are trying to solve their messy
Yeah,
CI/CD ecosystem?
yeah.
Okay,
Anyone who thinks their CI/CD, or more generally their DevOps stack, their DevOps pipelines, whatever you want to call them, anyone who thinks they could be better, that's the basis of the Dagger community, basically. So these days we have a Discord server that's super active, where people just come there and share their experience, talk about how they use Dagger or how they're thinking about using Dagger, and there's just a lot of exchange of ideas and code.
cool. So okay, so now we know that Dagger sits in solving the CI/CD ecosystem space, and it tries to solve the messy problems in the DevOps ecosystem and the CI/CD ecosystem that people are trying to glue for years now with all the technology that has been matured. So now, going through all those iterations, how would you define Dagger? So what Dagger is?
Basically, what we've realized is these scripts and this mess of scripts, first, it needs to be code. Really, you should think of the pipelines that deliver your application as software, because it's getting complicated anyway, right? It's a pretty complex machine, and it gets more complex as your application grows. And so the scripts are going to break, and they're going to become too complex, and they're going to get in the way. If you look at it as software, your current scripts and pipeline is basically bad software that you don't have a lot of time to fix. So Dagger is an engine that lets you rewrite one piece at a time from your pipeline into proper code. And that brings tons of benefits. First, more people understand the code because you're writing it in a language that's more familiar. It could be Python, it could be Go, it could be TypeScript. So this is a multi-language engine that we're talking about. I'll talk about that a little later. You can test, you can reuse components, right, that you used in your previous project. And of course, it's expected that it runs on any machine, right? These are standard environments, so it runs locally. And the other thing we do is we run all of these components of your pipeline in something we call a Dagger function. So it's written in code. It has a clean API. Here are the arguments to your function. Here's what it returns. There's proper types, all of that stuff, right? So if you call a function and it takes a URL as an input, and you pass it, something else, a number, it's going to fail, right? And then we run all of that in containers. That means every building block of your pipeline is going to run in this nice repeatable unit that we have in our ecosystem called containers. So we containerize the pipeline, we break it down into small reusable pieces that we call Dagger functions, and we make all of it proper code with a proper API. So that's it. That's Dagger in a nutshell.
Cool. So basically you have, so first thing is that you can now codify your entire CI/CD ecosystem,
Right.
and you can not only codify it, you can put that in smaller pieces as that you call it, or you call it as Dagger functions. So you have these small pieces of code that runs as Dagger functions that actually become your whole pipeline, and each function has a specific purpose to serve. And the more important part is you can run it locally, and you can run it as part of your CI
Right.
systems. You will have the same level of confidence that, okay, I have, just like containers, that I have it here, it works here, and it would work on the machine that is there on the cloud as well, or in
Exactly.
any other system.
Yep. And you develop your function very rapidly. You write a little bit of code, you run it, you see the results, you start over. So you get the full comfort of a modern development experience, just like the application that you're trying to ship, right? So the pipeline that ships the application gets a development experience just as good as the application itself.
And it also bring the, when we say the DevOps kind of bringing off to the dev side, so you actually now can codify the pipeline. So
Right.
I mean, I'm not saying that we force the developers to write the ops pipelines, but still they can do it because they know the app better, and they will be able to ship it the way they think the app behaves,
Yeah,
and the right set of parameters and all that stuff.
absolutely. And that's why that's where the modular aspect is super important. It's not the whole pipeline all at once that you rewrite in the language of your choice. Of course, you can do that, but it's each individual piece of the pipeline. And we'll see that there's nothing forcing you to daggerize your entire pipeline. That's what we call, adopting Dagger. You can perfectly, it's perfectly fine for you to pick one piece of your pipeline, maybe the most painful part, and make that a Dagger function. Maybe it's an integration test workflow that's just complex because you need to spin up several containers, you got dependencies, you got to bundle a bunch of different assets together. You have a lot of glue scripts, and it works differently in CI and locally. So you can Daggerize that, make it one nice Dagger function, but you can keep the rest of your CI/CD pipeline exactly the same, because Dagger can be embedded very easily in an existing stack. So it can run with almost any modern CI system. So you can run Dagger functions from GitHub Actions, you can run them from GitLab CI, from Jenkins, et cetera, et cetera. So it's a gradual process. And to your point about developers participating, a lot of times what happens is, especially as a team grows, is that different people will be familiar with different parts of the application stack, right? Maybe you have a front-end team that's familiar with JavaScript and TypeScript, a back-end team, maybe they're writing Go, a data team that's writing Python, and then you have the DevOps team doing a lot of specialized YAML or Jenkins files, Bash scripts, etc. But at the end, there's only one pipeline, right? You have to integrate it all together, because the I of CI it stands for integration. So you have to integrate at some point. And so in this scenario, forcing one team to write everything in one programming language, sure, it's code, so some things will be better, but it won't solve the problem of most of the team feeling like this is an alien language, an alien technology, something they're not interested in, and they can't easily get involved in. And that creates bottlenecks because, for example, as new tools arrive, remember this is an integration problem. If the front-end team has a new tool, or the data team has a new set of AI tooling now, and they want to incorporate that into the app, so it's working locally, they're happy, but it has to be added to the pipeline now to ship the staging and production, including the integration tests. So if they're not familiar with how the CI system works, they're just going to, open an issue or send an email to the DevOps team and say, I have this new tool. When you have a minute, can you add it to the pipeline? And it gets added to the queue, right? And so now you have an overworked DevOps team that's always catching up to everyone's tools. And you have frustrated development teams that are waiting for the pipeline to be updated. And so what happens is they use the pipeline less, right? They use a script on the side. You have this sort of shadow CI that spreads. But if it's modular and if it's code, then what happens is the data team can write their Dagger functions in Python, and the front-end team can write their Dagger functions in TypeScript, etc. And then the DevOps team will just combine these functions together, and that becomes the pipeline. So that's the key. It has to be code and it has to be modular for the problem really to be solved.
So code modular and platform agnostic, like language agnostic, that you can write in makes the entire pipeline with different set of developers with different set of skills, managing different components of the application, and they can write their own Dagger functions in their respective languages, and then it becomes part of the entire pipeline which is there.
That's right. You can also find Dagger functions that were created by the community. So it can be outside of your team also, right? Since Dagger is open source, there's an open source community. And we launched a search engine called the Daggerverse that lets you find all the Dagger functions that someone wrote somewhere, open source. And those are packaged in little modules. And so maybe there's a module to build a Go application, or maybe there's a module to get secrets from HashiCorp Vault, or to deploy to Vercel, right? Et cetera, et cetera. These are all real examples. They actually do exist. So you can also save time that way. Just kind of grab the module you're looking for, use the functions in that module, and connect them with your functions. And in that case, you don't need to know what language those functions were written in, because Dagger takes care of sort of magically allowing any Dagger function to call any other Dagger function across languages, which is very hard to do, but we did it. It works. So now you get to sort of build out of this common, Lego system where every language community can contribute their pieces.
So you still have that, love for Docker inside, and you build a Docker hub for Dagger.
Well, yeah, let's just say we learned from our experience at Docker Hub, and I think we avoided a few mistakes we made the first time. Yeah, like for example, we don't actually centrally host
it.
the artifacts. It's completely decentralized. Also, the Docker ecosystem is all about binary artifacts, right? These Docker images. That's made it pretty hard to reuse someone else's image as is. So it's a great obviously, it's a great standard for runtime interop. But what happens is most of the time you're running your own images, right? It's very rare that you'll go to Docker Hub and say, oh, that's a cool image, I'll just use it as is. Usually you'll end up rebuilding a version of it. In this case, we have a source code ecosystem, right? A Dagger module, which contains Dagger functions. It's just code. And so literally it's a Git repo, or somewhere on a Git server, you have a directory, and that directory is a Dagger module. And Daggerverse is just a search engine to find that. If you're familiar with Go modules, it works the same way. It's way less work for us because we don't have to host all these artifacts. And it's also, it leaves the community more in control. You can host it any way you want. You can call it whatever you want. Yeah.
Nice. So you touched some part of the next part that I wanted to ask, but just in case if you want to elaborate more on it. So whenever there is a new tool that comes into the market, the major issue with especially that I have seen in the cloud native ecosystem, is that they have already stuff that they have glued together that works, and they have stuff which is there. So basically people are lazy in adopting and changing the whole stuff that they have written. So you touched some part of it, that you can integrate it with your existing CI system. So what's the main, I would say, like, does Dagger replace the existing CI/CD ecosystem completely? And you can easily get rid of Jenkins or GitHub Actions or GitLab CI, whatever that is, or is it complementary to them? You can be like, you don't have to be diplomatic in a way. You can
no, of course. No, not at all. It's just it's a great question, because everyone making a product for the DevOps ecosystem, or any dev tool at all, should be asking themselves that question first. It's probably the most important decision you can make when you're designing your product. Is this a rip and replace, or is this an incremental improvement, right? And if it's incremental, how do you justify the complexity of adding one more thing, right? And so first of all, we all we do now is we just listen to users and we iterate with them. So anything I'm saying now is it's just the summary of everything our users are telling us. And basically, in the context of CI/CD, people have a lot of constraints, number one. And number two, there's a lot of diversity. Every CI/CD stack is different. There's patterns, but it's just all over the place. that's kind of why the problem has not been solved yet. Every problem that can be solved by, an off-the-shelf point solution, a tool, a specialized tool that does one thing well, that's done basically. I mean, there will be new ones, um, but what's left is the glue, and the problem with the glue is everyone has different glue. So for us, we had no choice. We have to adapt to the stack that you have. We had to make sure that Dagger can fit in almost any situation. And if you want to use it, just a little bit of Dagger in this little area over here, because you can't change everything else, then we make sure you can do that. So that's sort of Dagger's superpower, that it can be incredibly incremental. We're never pitching, okay, throw everything away, start over. That's always step one to adopt Dagger. No, it's the opposite. Usually we ask about pain. Okay, what's the most painful problem you have right now? And let's start with that. And if sometimes it's rare, but sometimes the answer is no pain. Everything's fine right now. Or, we're busy with other things. And that's fine. We're not going to force it. But now it exists. It's a tool in your toolbox, and eventually there'll be pain, and you'll reach for a Dagger maybe to solve the pain. Then what happens is, once you've had that first experience, you had a problem, you use Dagger to solve that problem, in a well-scoped way. A lot of times that goes well. You're happy with it. It saves you a lot of time. And then you start thinking, oh, maybe I'll use Dagger in other places. And then over time, Dagger spreads. And we have some users in our community that are all in. And if you ask them, they'll say, hell yeah, I'm getting rid of my entire CI/CD stack. You don't even need CI at all, because CI is just a webhook server that runs in Dagger and receives events. And then it calls more Dagger functions, because guess what? Dagger functions can call more Dagger functions. So if you're really into it, you can take it really, really far and reinvent your whole stack, but you really don't have to.
So yes or no questions. So if you are
well, I guess no, you don't have to throw everything away.
No, just so the question is basically.
Oh, I thought you were saying I wanted a yes or no.
No, not that. The next ones. So if like from your perspective, if someone is looking to replace their old Jenkins pipeline, do you say Dagger is the solution?
Yeah, no, definitely. And actually, that is one specific use case that we see. Sometimes a team decides to do a wholesale migration from one CI to the next, right? These days, there's a lot of, we call it the Jenkins exodus. Everybody knows, okay, I shouldn't be saying everybody, but a lot of people are thinking, okay, we should eventually leave Jenkins, but you need to find the right time, and it's a real project. It can be painful because there's a lot of lock-in, right? And so what happens is, if your team plans to rewrite everything anyway, then maybe it makes more sense to rewrite to this portable engine, so you never have to rewrite it again, basically. Plus, you get all these benefits. It runs locally, yada, yada, yada. And so that's one way teams start adopting Dagger. In this case, they adopt it kind of all at once. And sometimes it's more of a management decision. We don't want this lock-in again, right? Or we have multiple CIs in larger organizations. You have silos, Jenkins over here, GitLab over there, Circle CI over there, whatever. If we could have this portable layer on top, we could standardize the entire organization's logic at that level, at the Dagger level, and then choosing CI it becomes a matter of infrastructure. Who's giving us the best price? Which infrastructure is the team more familiar with? It gives them a lot of flexibility, and also leverage with vendors. They can go back and tell their favorite CI platform, hey, this is a little too much margin. I'm going to get some of that margin back, right? And if you're not happy, I can leave now. So we become a pawn in this complicated chess game between buyers and sellers.
Nice. One more thing before we get the hands-on part. Can we just go over like how Dagger kind of works and its basic architecture?
Sure. So we got to work on our diagrams. um, so, and actually, this answers a question I just saw in the comments. You know, do you rebuild and recompile everything every time? So, um, yes, Dagger modules are all source code. So when you say run this function over there, it starts from source every time. It builds everything from scratch every time. But the reason that works and it's fast is because at the bottom of the architecture diagram is a component called build-kit, which is the same component that powers Docker build. And we're very familiar with it because we read Docker and we were there when it started. And build-kit, basically, all you need to know is it's so powerful that the Docker file syntax barely uses a fraction of what you can do with it. Because build-kit can run any program that looks like a DAG, which is a directed acyclic graph, basically boxes and arrows. If you can structure your program as a DAG, where each node is its own parallel computation, and there's data flowing between the nodes, then build-kit can run that incredibly efficiently from primitives running in containers. And it can do that with great caching. And the caching is key because that's what allows this model to be so fast. Just like Docker build, could be very fast. If every time you want to call a function, a Dagger function, that's one node, right, in the DAG. If you call that function with inputs, with arguments that you already passed before, then build-kit sort of magically makes sure to reuse the result from last time, and you have a cache hit, and something that would take 30 seconds or 30 minutes takes a few milliseconds. And then we just generalize that not just to build, but to running anything in your DAG, any part of your pipeline. So builds, tests, deployments, and all the intermediary steps. We just make everything sort of cacheable. So that's build-kit at the bottom. Then on top of that, we have a GraphQL API. So it's just an HTTP API to control all the primitives in this engine. And that's what we call the Dagger API. And that gives you all the primitives you need for modern pipelines. So any operation like pull a container from a registry, execute a command in the container, copy files, mount files. We have secrets management built in, clone and git repositories, all those primitives. That's available in the Dagger API over HTTP. And then on top of that, we have SDKs in each language: Go, Python, TypeScript. Those SDKs are generated from the GraphQL API. That's done automatically every time we release the API. By the way, it's done using Dagger, of course. And so that gives each developer a very native experience calling the same API. And you're going to see all of that in the example. Bye-bye. Sorry, my kids are going to school. Right. And so then the last layer is what we call the functions runtime, where the codes that you wrote in your language that calls the Dagger API, that itself gets packaged automatically by the engine and run as an extension of the Dagger API, basically. And so that function becomes another primitive that other functions can call and compose. And in our world, a pipeline is just several functions chained one after the other. So you call a function, it returns an object. That object has other functions. You call a second function and then a third function. You do that dynamically through the API, and that's a pipeline. Yeah.
Cool. So I think caching is interesting, and just I'll take one question because that's very related to what you just said.
Mm-hmm.
But caching won't work on platforms not using hosted machines. For example, GitHub Actions, you get a random machine each time.
Right. So when the Dagger engine runs, it uses local storage for its cache. And so that question is a good one, because when you're doing that on a persistent machine like your laptop or a long-running server, then every time you run, you can reuse the cache data from the previous runs, right? So everything just kind of happens. In a distributed CI environment where you have short-lived machines like GitHub Actions, managed VMs, then every time Dagger runs, it's running in a machine with an empty cache. And so if you don't do anything, it's all going to work, but it's going to be slower because the cache will be empty. So that's completely true. But that cache can be distributed. And so now that we have a lot more teams taking Dagger to production, and we get that question a lot. We've been getting it for the better of the last year. We've been busy building solutions to that. One solution is a cloud service that we make called Dagger Cloud. That's optional, and you can plug your engines to it, and then it will orchestrate the movement of cache data across the engines and to an object storage service like S3 or something like that, or Civo storage. So that works. It is an early access, experimental, and some people are using that happily. Others are saying, "Look, I work at a big bank, or I work in this is a government project." I mean, there's all sorts of deployments of Dagger out there, and not everyone can use a managed storage service by a startup, and so. Actually, pretty much the next priority, like in the next month or two, we're adding more customization. So you can install what we call a storage driver, which basically tells the engine, okay, you got to synchronize your cache data with this object storage over there. And some of that has been a lot of the foundation for that has been laid in the build kit project. Like a lot of the plumbing exists, but it doesn't work great. It requires a lot of careful fine tuning. So we're going to make sure it works great, sort of out of the box. There's a lot of hard engineering to do that, but that's what we're here for.
Yep. I think that's a good question, and you have already described how you have been working it and getting this question repeatedly and working it towards solving it by having a storage layer of the object store somewhere, and then using that instead of the local one, even when you have different machines for a GitHub Actions, and it's still you can take the benefit of cache.
Yeah. The caching is really key, and it's some of it. I mean, we're describing this with words. Some of it is just really easier to show or to experience, to be honest, but because it's simpler to use than it sounds. But there's something for some of you that are old enough to remember the world before Docker build. Docker build was very weird, because if you look at it, it looks like you're going to do everything every time, and that seems a really stupid thing to do because it's going to be slow. So instead, what everyone did before is they manually wrote logic to check for steps that were already done and then not do them. You see what I mean? So every build script, every makefile, anything that required the equivalent of building a container. Maybe it was installing software in a server, building a VM image. It had these kind of manually optimized caching steps. And so it was sort of like writing assembly language, where you manually optimize everything. And then in this DAG model that Docker Build introduced, and we're introducing even more broadly, to everything in your pipeline, all of that stuff you can just remove because it just happens automatically. So it's like going from manually written assembly language to a modern language like C. I guess not so modern anymore, but you use a compiler, and the compiler creates the assembly, the final machine language. And the compiler is going to optimize a lot of that way better than you could. And in some cases, especially in the beginning, some of your optimizations are better than the compilers, but it never lasts, but even if it does happen that sometimes there's a pipeline that's so well optimized by hand that you switch it over to Dagger and it's not actually faster. That does happen. But once you've switched it to Dagger, you can change anything at any time. Like you could take 5 minutes and change something in the pipeline completely. and then on the next run, it's still going to be cached. But with manual caching optimizations, you have to spend another few hours to kind of change everything, and that part, and you know, Kyle can confirm. I can see Kyle nodding because he's done that, but it takes a lot of time. So someone in the team, the DevOps expert, is going to have to go back and manually optimize everything, and now they don't. So it saves a lot of time.
Yeah, so I think that's pretty cool, and that sets the context for what we are going to do next, which is the hands-on workshop. And so now is the right time to kind of get your laptops in.
Okay, I'm gonna share my screen. Does this work?
Yes, it works.
Okay, cool. So here's the Dagger website. Let me move it over here. So if you go to the Dagger website, there's this link called Daggerverse, and that sends us to the search engine I was talking about, and it shows us some of the modules that people have written somewhere on the internet, and you can search for them. So my little scenario is going to be, oh, hey, I'm on Kyle's team, and I'm trying to work on the CI pipeline. And as we know, the CI pipeline is made of lots of little tools glued together. And something that you do frequently is you evaluate a new tool, you know, a new component, because the team asked for it. So here I'm going to do a little bit of an ad for friends at ChainGuard. They launched a Linux distro called Wolfie. That's like it's a fork of Alpine Linux with some benefits. And so I want to try it. So I'm just going to go in the Daggerverse and look for it. And so I see, okay, there's 3 matches. This is a tool related to Wolfie, and here's one called Wolfie. So now I'm looking at the page of a Dagger module, and I can see, okay, Wolfie is a container native Linux distribution. Yep, that's what I'm looking for. And here I can see basically the API documentation for this module. What functions are available, what types, and then I can see examples. So here I can see there's a function called container. Build a Wolfie Linux container. It returns an object, a type container. Okay, it seems logical. And as arguments, you can pass an array of strings. That's the name, a list of packages to install. Okay, and here are examples. Notice that there's examples in TypeScript, Python, Go. So this is for calling this function from my own function. But there's also a shell example. This is super important. Any function from any module, you can call directly from the command line. You don't have to write code to call a Dagger function. And that's usually the entry point. Here, well, it's adding the version. Everything's pinned, you know, this is the git commit. But basically, this is the part that's interesting. Dagger call. So I'm going to go to my command line. This could be, I happen to be in some Git repo, but this could be anywhere. So if you install the Dagger CLI and nothing else, the same command will work for you, right? It's completely stateless. Okay, so I'm going to say Dagger call to call a function, -m to specify the module, and well, obviously this is my module. Just not leaving anything to surprise, but in this case, I put the module in. It's not its own repository. It's in my little Daggerverse repository, which has it's like a collection of my modules. It could be anywhere on as long as it's Git. Could be in a mono repo or not. And then I'm going to call a function. If I don't remember which function, I can always call --help. And you can see its Dagger engine is loading the module. Oh, of course, something's going to happen to my internet. It should definitely not be that long. No. Where am I? Okay, let's pray for a second. Okay, I don't know what happened, but okay, so you can see, oh, here it is. There's a function called container. So the CLI does actually something pretty advanced, which is that it loads the module, it inspects the API of the module, and then as a convenience, it shows me the functions in that module at the top level as commands that I can call. And then the arguments to that function, to those functions, will be showed as just flags. So that gives me a familiar CLI interface to call any function. For example, here I can call container. If I don't remember what arguments I could take, I could pass help. And let me skip that for a second. Yeah, there you go. -- overlays -- packages. Notice that this is the same as here, right? So here I'm just going to call container. I'm going to pass, I don't know, get, I want get and SSH. And I'm going to call that build function. You can see it's doing things. And it says container evaluated. So the build is complete. So what happened is it built a container object, and now I have to decide what to do with it, right? So now this container object, this is a primitive in the Dagger API. Remember I said you have all these primitives, the run containers, etc. So now the container object that was built by this function, what do I do with it? Well, let's inspect all the stuff that we can do. It's because it's a primitive in the Dagger API, you can do a lot. You can do all this. And this is basically everything you can do in a Docker file, roughly. You know, I want to add, I want to execute a command, I want to mount a file, I want to do this, I want to do that. And so I can now chain. So here, I'm going to do something simple for now. I'm going to call a function called terminal, which gives me an interactive terminal in that container, like an ephemeral session. So this is a pipeline, right? So Dagger call, the first step of the pipeline is to load the module. So it calls the Wolfie entry point function. Then it chains a call to the container function, and then it chains a call to the terminal function. So I'm literally composing a pipeline from the shell. So if I run this, you can see what's going on. So it's calling Wolfie container, and then boom, I have an interactive shell in this Wolfie container. So I can look around, you know, Git is installed, cool. SSH is installed. Oh wait, I want rsync. Exit the oh, that's a bug. Exit the function, change something, run again. You can see it's installing one more package. Boom, have another container, and now rsync is installed. So that's an example, a very basic example of this dev loop that we're talking about, right? For something very simple. Now let's say I want to run this container, but I want to mount a directory in it, right? So maybe, for example, yeah, I'm in my project. So I want to insert a call after building the container, but before calling the terminal. I'm going to add with mounted directory. And this one takes 2 arguments. So let me what is it? Shift enter. Can't remember. Trying to make my, oh, it's escape enter. Trying to make my man look prettier. This is better. With mounted directory, so I'm going to mount something, source directory, and then I'll mount it at /src. And so here, I can pass a directory object. And the directory object is, it could be anything that produces a directory, right? These are dynamic types. I could pass the output of another function that just created a directory on the fly for me. Or it could be a local directory, or it could be pulled from a remote Git repository. So here I'm just going to say, give me the local directory. So the CLI takes care of that. Let me try again. You can see it's, oh, it happens too fast, but so now if I go to src, there it is. I'm in my container, my Wolfie container with this directory mounted, but I want the work dir to also be src, so I can just see it as soon as I open the shell. And here we are. If I want to mount a remote repo, for example, I want to see source code of Dagger at the branch main. Okay, here it is. That's the source code of Dagger. So you get the general idea that I'm composing these pipelines on the fly from the shell. And then this is what I would, either call directly or call from my makefile or from my existing tooling. And also, this is what I'll call from my Jenkins configuration, my GitHub Actions configuration, right? This is the entry point into Dagger land. You call a function from the command line. But then what happens is this command is getting a little long. It's turning into a whole script. Maybe I want to do something a little more, for loops or an if, and that my shell script gets too complicated. I'm thinking, well, I thought the whole point of Dagger was to remove this messy glue scripts. Now I'm just writing messy glue scripts to call Dagger. But so that's where you write your first function. And I'm just going to demonstrate that you can do this quickly. And then I'm going to stop there. And then I'm going to hand over to Kyle to do some real stuff. But let's say I just want to create a module. But first I need to decide where to create my module. So I guess I'll just do it here for there's a CI directory. I'll just do it here. Okay, I'm going to Dagger init demo. This is going to create a Dagger module called demo. In your case, if you're creating a real module, you might do that at the root of a fresh new Git repository or a subdirectory of your app repo. Kyle will probably cover like realistic things to do. But the point is it could be anywhere. So as you can see, a Dagger module is just a directory with a file called Dagger.json. And if you look at the contents, it just says, hey, I'm a Dagger module, I have this name, and this is the engine version that created me. Very simple. And then I want to develop functions in my module. So I'm going to run Dagger develop, and I need to choose an SDK. So Dagger develop, it's really the command to control your SDK to help you develop. I want the Go SDK because that's what I'm familiar with. It's going to generate some source files. Just put them here in the current directory. There's no dependency on Go on your machine. Everything's containerized. The Dagger SDK itself is a Dagger module that has special functions to generate files and build your function, etc. That means you can develop your own custom SDKs. And in fact, in the Dagger community, there are a whole group of people that are actively creating SDKs for Java and Rust and Elixir and PHP, things like that. And if you're interested in that, you should totally join the Discord. So now I got a bunch of files that were created. I'm going to edit this one, main.go. And nope, that's the wrong main.go. That's the one I want. And it just generated an example module. So this is a fully functioning Dagger module with two functions. One function called container echo, one function called grep-tier. And I'm going to get rid of this. This all just generated description. And here I'm just going to say, test Wolfie, I guess. Test Wolfie. I'll just call it Wolfie. So it's a build function that returns a container. And it's going to call the Dagger API. This DAG object is how you call, it's your entry point of the Dagger API. So for example, I'm going to say, let me just get that shell command from before. Kyle, Sam, I can't see you. Is everything okay? You can see the screen okay? You're following along? I'm on time. Everything good?
Yep, all good.
Okay, cool. Okay, I'm almost done. So dag dot something. Aha. So the first thing I need to do is access this module, right? I'm not going to do this dynamically because I want the types, right? I want actually my IDE to autocomplete function calls from this Wolfie module. I want the types to be known. So what I'm going to do is install the module. So here I'm going to call Dagger install of this module from within my existing module. So that's going to fetch the source codes, loads, et cetera, et cetera. You can see the cache makes it fast. And then it does two things. It's going to add to my Dagger JSON a dependency. Notice it's always pinned to a specific commit. So, you have proper version management. But also, it just did something else that's really cool. It loaded it inspected the module's API on the fly. And just like the CLI generated this cool set of CLI flags to match the API of the module, here the Go SDK generated a Go client for my module to call, right? And so it's here, there's a dagger.gen.go. If you look in that file, you'll see terrible things, but don't look at it. You don't have to because it's generated magically. And now, if my IDE works properly, I can call dag.wolfie, and now I have an entry point into this module. And you can see container, and you can see the options here. This is a Go pattern. For those of you who know Go, if an argument is optional, you express that with a structure, with fields. So here I'm going to say packages. So if you're a Go developer, you'll think, oh, this is cool. This is the way I usually develop in Go. If you're not, trust me, it's regular Go. So here I'll say I want SSH, and I want Git. Same stuff I was doing before, basically. And then with mounted directory. So I'm going to say I want src. Notice the source directory here. What do I mount here? So this is where, I'm going to take it as an argument to my function. So I'm going to say, okay, this function takes the source argument of type directory. And I'll even add a little description. Source directory mount in the container. And build a demo. Okay, so here I'm just going to pass source. So this is the part that's really nice. You have types for advanced artifacts like a container or a directory, and you just pass them around like regular variables. And you can even modify them on the fly. For example, if that source, if I want to add a file called hello to that source, I can say source equals source with new file at hello.txt. Hello, cube simplify. So these types are not fixed, static. They're dynamic artifacts, and you can receive them and not know where they came from. In my function here, I don't know where this source came from. Did it come from a Git repo? Did it come from another function? Don't know, don't care. But I can still mess with it. And really, under the hood, I'm just adding nodes to the DAG. I'll just pass this here. So I'm just going to pass. I'm going to mount a slightly modified version of source into s/src. And then with workdir. And that's it. I'm going to just return that container. Let me remove that stuff. Oh, I'm not going to call terminal. I could actually return a terminal, but I'm going to let the end user do that. So maybe they want to do other things with the container, right? Okay, so yes, all right. I can quickly inspect, what are functions available in this module? If I omit the -m, it's going to look in the current directory, right? So I can do this. It's the same thing. And it says, okay, there's a function called Wolfie, build a demo Wolfie container. I almost wish I'd made a coding mistake here. Let's see. I want to show you that this is just a regular dev loop where the SDK is building on the fly and says, oh, you made an error at this line. What the hell is this? Okay, remove it, save, run, and we have that nice dev loop again. So now I can call Wolfie. Remind me, what are the arguments? We should change that. -- source, the source directory to mount in the container. That's my comment, right? I wrote that here, and now it's here in the CLI. So I'm going to call Wolfie -- source. And you know what? I'm going to pass the source code of Dagger again. Oh, and then give me a terminal and that. Okay, I have the source code of Dagger plus normally. Hello. So as you can see, this is a very useful Dagger function. But yeah, that's it. That's my little function. So now I could go and change my scripts and my CI to call this. to instead of this the 8-line shell command from before, and that's the process of Daggerizing. You call functions, and when you have too much logic, call one function, you write a new function that calls the other functions, and then you just keep going, all the way to having, in some cases, your whole CI will be one function that takes the raw GitHub event, for example, and then decides what to do. So you're completely free to do as little or as much as you want, because it's just code. If I wanted to push this on Daggerverse, literally I git commit, I git push, I tag it, git tag just a regular semver tag, and then Daggerverse will find it, basically. I'm gonna leave it at that.
Perfect. All right. So yeah, we're gonna take all those cool concepts that Solomon just showed off, and then put them to use in like a slightly more like real world example, which is this repo here. So if you want to like follow along, you can clone or fork and clone this repo. And then if you're watching from the future, I'll also add like all the commands that we're going to run through this into like a README here, so you can easily copy and paste. But if we're doing it live, then yeah, we'll go slow and get all the commands out. So this is our project, and before we start thinking about Daggerizing it, let's familiarize ourselves a little bit with it. So I have it open in VS Code over here, and there's basically two components to this super real world project. There's a backend API, and it's basically just a HTTP endpoint that returns a greeting. So we have this greeting function down here that says, "Hello, Daggernauts." This is written in Go, and it's got super great test coverage and all the things you want with a backend API. And so we can run that real quick. If I say, go run this, and then it's running probably, and we can localhost 8080. And so now we can see our production API running on our machine. So that's all great if we have Go on our machine, or if all the devs are running the exact same tool chain, but we're going to Daggerize this so that we don't have to worry about that in the future. So there's the back end. We also have a really cool front end component of this stack that's actually a Hugo site. So within this website directory, there's basically this Hugo stuff, and Hugo is a static site generator in Go. That's really an implementation detail. You don't have to worry about that. But the main idea is we've got this front end, and we need some way to build it, and probably some way to serve the website and do all these things so we can iterate locally on it and do all that fun stuff. So that's the project. So if you've cloned it now, that's what you have on your machine. And then the next step, I guess, would be to make sure that we have Dagger so that we can do all the things that Solomon just showed off. So if you go to docs.dagger.io, and I can make sure that that's shared as well. Then on the installation, you can use Homebrew to install from the Dagger tap. We have some binaries on GitHub releases that I think the install script pulls from, and on Windows. Best of luck with that. There's a PowerShell script. I can't help you if you run into anything because I don't know pretty much anything about PowerShell, but that's okay. And so, yeah, let's start Daggerizing this application. So just like before, the first thing we want to do is create a Dagger module, right? Because we've got all these functions out there in the Daggerverse, and we're going to piece them together to create our pipeline to build the back end and front end. So first, I'm just going to run Dagger init, and this is going to create. We'll see all the Git changes on the side here. It's going to create a Dagger JSON. And so literally all it has right now is like the name of our module, which is by default just the directory that we're in, and then my engine version, so that I know, if I'm running from a different Dagger version, I know what kind of this is expected to work with, basically. So anyway, I've got this, but we don't have any code yet. So we want to decide like what SDK are we going to work with. And in this case, let's say our platform team works with Go mostly. So we're going to say Dagger develop, because now we're ready to actually write some code. And we're going to say our SDK is going to be Go. And then when we run this, it will basically generate that module for us. So we can see a few things got added here. The SDK is specified as Go. And then it says source Dagger. So if we look in our project, it's created this directory called Dagger, where it basically generated this module for us. And so again, the same thing we just saw on Solomon's screen, we have these like template functions that basically give you an example of how to get started with your module. And so already I can say Dagger functions, and it's going to see that we have these two functions available for us to run, the container echo and the grepter. However, they're not very useful for this application. So let's say the first thing we want to do is we want to be able to build the front end and back end components. And let's say that in our organization for our front end and back end, we have kind of two separate orgs that maintain those concerns of the project. And so they can actually maintain their own module that is just basically an interface for their front end and back end. And so let's kind of mimic that and say the front and back end will have their own module that does the build and maybe other functions that are going to get exposed for those. So we're going to go a little bit further here, and we're going to go into that Dagger directory and make a backend directory. Let's make your backend. And then within that, let's make another module. So we can say Dagger init here within backend. So now under Dagger backend, I've got a new Dagger JSON for my backend module. And I can say, and we'll stick with Go for this, but if you're more familiar with like Python or TypeScript, literally nothing changes within how this all interacts. Like you could write this module right now in Python or TypeScript, running the other supported SDKs for functions. And because it's all based on the same Dagger API, like the code's going to look roughly the same, but native to that language. So we're going to say SDK Go, and our source for this module will be the backend directory that we're already in. So now, once again, we're going to generate some stuff here, another like basically empty module within the backend. And so here, this is where we're going to say we want to be able to build. So we'll have a function called build within our backend module. And that should take in a directory of the source we want to build. So we'll say directory. And then if we look at that, we can see that that's like a Dagger primitive that has all these things we can do with directories. And so the build should probably return a file, right? Because we're going to take that, the source code for our backend API, and basically return the compiled binary of that Go code. So we can say this should return a file. And again, if we look at this, this is a Dagger primitive that has a bunch of stuff we can do with it. So let's do the stuff. So again, but before we actually dig into like modules out in the Daggerverse, let's see what it's like to actually just kind of write something from scratch, just using the primitives. So in this one, where we're taking in some Go code and we want to compile it and return the binary. So we can start with and DAG is the reference to the Dagger client, which we can see here, the super helpful type in. We can say we want a container, and that's going to be from, let's say, Golang 1.21, or maybe we'll say Golang latest. Let's spell that. So now we have a Golang container, and we're going to start building this pipeline. So again, just like we saw before, we want to say we'll put a directory in this container. And so we can say with mounted directory at the path source, we'll put in our source. So if you look at the type hints of this function we're calling now, like it's a function of container, and we want a path where the directory should be mounted, and source would be the directory itself. And then there's other options that we could pass there as well if we wanted to. And that will just return the container with this modified directory passed into it. So we can continue to chain on that. And then we'll say with workdir. So now any commands we execute will be in this path we specify. So we can say, now at this point, we've got a Golang container with our Go source mounted into it, and we're in that directory. So now any commands we execute will be from that directory. And now we can say with exec, so let's actually execute a command. And that takes basically a string array or a string slice, which are the arguments that we should run. So we're going to say go build dot. And so now we've got a container that's, again, got our source. We're in this directory and we've run go build. And maybe we can specify the output file should be called greetings. And now, since our function wanted to return that compiled binary, then we can say file. So we're, again, container.file. So we're going to get a file from that container. And that's going to be /source/greetings. And then we want to return this. So yeah, and I know we went through the whole chain a few times, but just one more time, we've got this pipeline now. We've got a container with our project in it. We've run go build and we're returning a file. And so if any part of this fails, like if this go build fails, then we'll get that error back from the calling function. So we don't have to worry about checking if this file is actually a thing. Like we know that this go build had passed and so on. And so already I can say, let's go back to the root of the project here, and I can say Dagger, and then I'm going to specify -m for the specific backend module. So it's under Dagger backend. And I can say functions, and we should see our build function here. And once everything's loaded up, so, and we didn't update the comment, that's okay. So it's build, what are we, okay. build the backend binary. There, we can see it. Okay, so now if I run this again, we'll have an accurate description of what this function should do. Build the backend binary. So now if I say call build, so we're calling the build function from this module. And again, we want to pass in source, and source will be my current directory, which is where our main.go for our application is. So if I run this, it'll go through, and again, we're doing lots of things within this pipeline. Like we're pulling the Golang latest image. Oh, perfect. We messed something up. Oh yeah, I think it wants this after. So this is great. So we saw an error in our pipeline, and again, it didn't just give us a file or try to give us a file of this path. It said this part of our pipeline failed, and we can pretend I did this on purpose, and we'll say, oh, I see it wants this. Let's see, there's probably a more useful error message in here somewhere, but I think what it wants is this dot to be at the end. Actually, the dot should be optional anyway.
It says something about a malformed import path.
Yeah, because I think the -o should be in the beginning, right?
This is my moment to shine. If I can fix this error for Kyle, I'll impress him.
Yeah. Let's see if that fixed it. If not, then we'll see. So we're installing our dependencies. Okay, file evaluated. So our pipeline passed now that we fixed our build command, and it didn't actually do anything, right? Because again, it's like we saw earlier, like there's tons of stuff we could do with a file. So in this case, let's actually export it. And export means basically I want it back on my machine from where I'm calling this from. So our path will be greetings. And so run the pipeline again. It should be pretty much instant because we just ran it already. The only thing we're changing is what's happening after that pipeline. And so it exported to my current path as greetings. So we can see it there. If I inspect it, we can see that it is ARM64 because that's the machine I'm on. But as you might be able to see by the top of my machine here, I'm actually on Mac, and it just built a Linux binary because, again, all these pipelines are running in containers. And since I didn't tell it otherwise, it said, okay, I'm running in like Linux ARM64. So that's what we want to build our output for. So let's make that configurable now because we want to be able to build this for whoever is calling this. So let's say our source, we'll add some comments, backend source to build. And then we'll say the OS to build for, and this will be, we'll type our argument first. So OS string. So we're passing in a string for the operating system we want to build.
I think
and this should be
fail, maybe. Does that work now?
It should be good. Yeah. I'm on latest Dagger where we've smoothed out some of the rough edges.
OS used to be a reserved keyword, so I had to type operating system everywhere. I'm going to go rewrite everything to OS.
We'll see. Now you're making me nervous, but we'll hope it works. So we have another flag here, OS, and something I've added here is this plus optional. So this is basically a notation that is standard across all of the Dagger SDKs that says this flag for this function is an optional argument. And we can even set a default for it. So we can say plus default equals Linux. So if we don't pass anything in, then it's going to assume that we want to build for a Linux operating system. And then while we're at it, let's also pass in the architecture we want to build for, since not everybody is running ARM64 yet. Someday. So we'll say the arch to build for, and this one will be optional as well. And this will be arch. And this one, rather than setting a default in the parameter, let's see if it's not passed. So if arch is empty string, so the user didn't specify an architecture basically, then we'll use the goes runtime call basically to say whatever architecture we're currently running on. So what that looks like is arch equals runtime.goarch. So this is basically like if they don't pass an architecture, we'll have an empty string. And in that case, we want just whatever architecture we're currently running on. So we'll make some assumptions. And so now, if we call this again, let's get rid of our file first. So I think it would just collaborate anyway, but we'll get rid of it so we can see that this is all real. And so we'll say OS Darwin. And so now hopefully we'll get a binary that I could actually execute. And so we have to rebuild again because we've changed something in that kind of the beefy part of that pipeline where we're actually doing the go build. And we've got a new file for greetings. So we could say file greetings and, oh, okay. So the important part is all these cool args I just added, we should actually use them in our pipeline, right? So another great example of we totally did that on purpose. So we'll say with environment variable, and this, so now we're setting environment variables in our container. And so I can say go OS is OS, and we'll copy paste that and say go arch is arch. And this is basically the Go's way of specifying like cross compilation. So I can say this is my target operating system architecture. Other languages have other ways. We could also in our container, one of the container options for creating this, if we just go out here and look at it, it doesn't like mine, but if we go over here and say client.container, you can pass in these container ops, And one of the options is platform. So if we actually wanted to run like an emulated platform for compiling a language that's not as cool as Go and doesn't let you just tell it your target, then we could specify a platform here to say we want to run on, like AIX or something, and build a binary for that. So now that we've passed these environment variables in for Go, then if I run this one more time, there we go. And so again, we're passing the current source, and our OS is Darwin. And we didn't pass an architecture because it's optional, and we just will let it assume the architecture there. And it's going to do our build. This time it's actually rebuilding. And now if I say file greetings, hey, we've got one that we can run. And if I actually run it, it's running, and I can say host 8080, and it's there. So we were able to build successfully. We built a module for the back end. Now let's build one for the front end. So again, we've got these two different teams in our fake organization, the back end team that just wrote this module, and now we want our front end team to basically write a similar module that's called build and takes in a source directory. And that way, as kind of the platform team that doesn't work directly with these two teams in all their code they're writing, we can just assume that there's this function and some parameters for it. And we'll see in a minute from our code, we can easily tell what their function should look like. But let's make a new module now for front end. So we're going to go again into that Dagger directory where we made our backend module and where our main module is. And I'll make a directory for front end. And we'll go into that and initialize a module here. And I can say, we'll do this one and Go again just to be consistent. But again, you could use whatever language. If this front end app was like a React app or something, then maybe we'd do this in TypeScript. But this one, like we said, is Hugo, which is Go based. So we'll say Dagger develop SDK is Go. Source is right here. And so once again, we have generated all the things in this front end directory. And we've got this boilerplate module. So now again, we want a build, and this will be, we'll take in a source directory. And since we're compiling a front end website, we'll just return the whole directory that is our website. And so now we want to do stuff with Hugo, and we could like use a Go base and download the CLI and whatever other dependencies we need to build. Or we could do it the easy way and go up to the Daggerverse and say, is there a module for Hugo? Oh my goodness, there is. Okay. And so we're going to use this one. And so from this, we can see Hugo as a build function where we can pass in a directory, environments, and all these other parameters. So someone's already taken their time to put this together for us. So let's just go ahead and use that. So if I say Dagger, I think the whole install was there. So it's Dagger install Hugo at that specific SHA. And we'll go ahead and find that module. And then in our Dagger JSON, we've got this dependency on that Hugo module from GitHub. And so just to highlight that real quick, like when I did that Dagger install, like I'm not actually installing anything on my machine. The only thing we're doing is Dagger's looking at that module and seeing like, okay, it's out there, I can find it, and I'm going to add that to my dependencies file. And so during runtime, it'll fetch that from this path on GitHub. But in my machine, we didn't actually do anything other than add this to my dependencies and regenerate all the stuff that Solomon told us not to look at. So we'll just assume that's there. Now from the Dagger client, I can say dag.hugo. And so this is our Hugo module from Daggerverse. And I can say .build, and it already knows about all the things that this module can do in my editor. And this is just because of that magic generated file. And so we can say it needs a target directory, and then there's a bunch of optional stuff. So if we just pass in source, and what is this? This is return a directory. It does. And so if we do that, now we've basically got a function already to build our Hugo site just from using this Daggerverse module, and we didn't have to reinvent the wheel like we decided to do in our backend module, right? So we've just built that Hugo site. So if I go back to the root of my project and I say Dagger-M Dagger front end, where we built that front end module, and I can say call build, and our source will be the website directory. We can say /website. And then that returns a directory, so we can say export that to path should be built. So now it won't just dump our whole website in our current directory. We can put that somewhere else. And so now there's tons of stuff happening, but we like pulled in an image, put Hugo in it, install all the dependencies for Hugo, all the stuff that module did, as well as load our actual front end module, put our site inside that, run the Hugo build, get back a directory, and actually export that. So if I look at build, here's our compiled front end site from that front end module. So we'll get rid of that. And do we still have the greetings? It's funny permissions on that image, apparently. That's okay. So, oh yeah, the greetings binary is still there too. Let's get rid of that. Just cleaning up. So now again, now we've got the front end team that's built their build function. We've got the back end team that's built their build function. So in our main module, from let's say the platform team's perspective, let's write a module that basically does the build of our whole project. And so now it should be pretty easy because we've got these two functions basically. So if I take in, again, our source directory, and this will return a directory of like, let's say our binary and also our built website, return a directory. And so now we can just use those two modules we built. So if I say from the root of my project where my main Dagger JSON is, I can say Dagger install Dagger/front end. And now it'll see like, okay, I've got this module in this local path of my project. Maybe we'll look at what that dependency looks like. So again, remember the one before had that long GitHub URL. And this one is just like, oh, it's a local module in this subdirectory. And so we'll do the same thing for backend. And so now we've got the front end backend team in this like monorepo, and then another platform team maintaining this main module. And so now I could say backend build is from dag.backend .build, and we can see again like it knows about the attributes of that module that we just had, which maybe doesn't seem as magic because it's local, but I promise it's magic because it's a separate module. And we can say source. So now we're getting our backend build, and we can do the same for our front end. Front end build is going to be dag.front end. That's not it. Front end .build. And for the front end, we want to pass in the website subdirectory, right? So we can say .directory website. And so from here, like we have our whole project, and we just pass in that website subdirectory. And so now we want to return, like I said, a directory that contains both of these things. So we can say dag.directory. So this is just an empty directory now, which this super helpful thing tells us. So we can say .with directory. And so now we're going to have put our front end build into this directory as, say, website. And that'll be, so that's the path of the directory we're putting in it. And then we'll put in and build. And then we can also say with file. So now we're adding a file to this, and it'll be at greetings, and that's our backend build. Okay, so now we're building our whole stack with this basically. If I say call build help, so this is our build function that we just wrote right now. And it's gonna basically build the whole DAG here and say we are returning a directory. So these are all the things we can do with the Dagger directory. And also our flag is source. And so if we say source dot, so this is our whole project, so I'm at the project root, and we can export this to let's say build again. And so now we can build the front end and back end using the Hugo module and using the Golang image for the back end. And we have this big dependency graph. It's all good. We can look at build, and we've got under the website directory, our compiled website, and at the root, the binary. And so if we look at, say, file build greetings, it was built with like the default arguments, so we didn't pass anything in. So now we've got a build, and I think we should take this maybe one step further and say, okay, now I'm developing this application. I want to be able to run it somehow, right? And I don't want to worry about like needing all the Hugo flags and the Hugo binary to build the front end. I don't want to worry about the Go tool chain to build the back end. So let's add another function to those modules called run that actually runs these things as a container. So starting with, let's say starting with the front end to make it easy, because that's super simple. We've already got our build that compiles the thing. So let's say we make another function called run. So this is just Go syntax for saying we're extending the front end class, basically, or the front end type. I can say run, and that's going to take in a directory. And let's say in this case, we just take in the source again, and we can just rebuild it because we've got this function. And this will return a service. So service is another Dagger primitive that's basically a container that is runnable. So it can have lots of attributes like ports and host name and endpoint, and you can start and stop it and do all these things. So it's basically a special container. We could also just return a container and do and turn that into a service, but we'll do that in this function. It's okay. So we want to get a service that can actually run our Hugo site locally or wherever, I guess. So first thing we need is to compile that front end. So we can say the web, we'll just call this variable web, is our f. So this is like itself, right? So f.build source. And actually, one of the things, fast forwarding to making mistakes and then walking backwards, Hugo, just like a lot of front end frameworks, has like different environments because you have these configurations that determine like what the host name is and all these things, so it knows where it's running basically. And so in this case, when we're doing this build to run it locally, we want to say we want to use the dev environment that has like the URL as localhost and has the backend API as also localhost. So anyway, we've made these mistakes in this parallel universe, and we know to not make them again right here. So instead of calling our build function, we want to call this Hugo again, but with some extra arguments. Hugo build ops. And if we look at that on Daggerverse again, the Hugo build, it has this optional argument called Hugo env, which is our environment for Hugo. So let's pass that. Hugo env is going to be dev, which again just corresponds to that config file we just looked at on the front end component. So now we've got the right one for building for localhost, and that is our compiled front end. So now we want to serve that. So what's good at serving websites about Nginx? So we can say return dag.container, and this is going to be from there we go, Nginx. And then we want to put our website in it, right? Got a little ahead of itself with the S service. So it looks like VS Code was like, this returns a service and this thing gets a service. So this is what we want to do. Or maybe it's just alphabetical. Who knows? We'll pretend it was super smart there. But before we turn into a service, we also want to put our website in it. So we can say with directory. Nope, none of that. With directory. And the path will be using my magic Nginx brain. It's /user share Nginx HTML. So this is like the default directory where Nginx serves websites from. We could also put this somewhere else and then tell Nginx to look at a different directory. But we happen to know that that's the right place to put that. And we'll put the web build in there. And missing a period. There we go. So now we have an Nginx container with our built website in it with that dev environment, and that's going to be as a service. So now we could do, if we look at our front end call from before, we could do call run. And so we pass in that same source as our website and see what this returns. So we're calling this function run that we just put together. And it says for a service, we have to tell it basically what we want to do with that service. So if we say, okay, what are my options if I run help? So there's some flags, but we can also say, what's the endpoint of my service, host name, and so on. But we happen to want to run up, so we can actually run the service on our machine. So it says it creates like a network tunnel, so we can see our service running. So say up. I think that should be pretty instant because we haven't changed any of that pipeline. No ports forward. Okay. So one important part we missed here was we want to say, we want to tell it what exposed port the container should have. So we can say with exposed port, and Nginx is going to list on 80. But I think when we run this on our machine, you might need privileges to run at 80. So we can actually say -- ports. And let's go to 8081 for the front end. So I put 8081:80. So that just means like our local 8081 will forward to the service's 80 port. And then Dagger will connect all the dots there. So once this is up and running, we should be able to pop back over to Firefox. So we see this is output from Nginx now. So if we hop over here and say localhost 8081, sweet. So here's our front end application in development mode. And now if we open the console, we can see, okay, it's mostly up and running, but we have some stuff not rendering because it doesn't know where to find our backend API. And so theoretically, now we could do the same, like let's make a run function for our backend API, and then we could run the whole stack, right? So we go back to our backend module, where again, we had this build function that does all this cool stuff. So let's add a run function. So we'll say func backend run, and this will once again take in a source directory and return a service. So in this case, we can call this build function, and we know exactly what we want for OS and Arch, because again, since this is running in a container, we can pass in Linux for that OS. So we'll say our bin is b.build, We pass in our source. We pass in Linux for the OS, and we'll pass in runtime.goarch for the architecture, because we just want it to run like on whatever native architecture that we're using in our machine. So we've got a binary. Now let's put this binary in a container and return that as a service, basically. So here we're going to kind of construct a service from scratch. So we can say return dag.container.from, and this time let's use a Wolfie base, because it's lightweight and also not going to have any vulnerabilities in it. So you can say cgr.dev chain guard. It's really hard to spell some of these words when you're saying them out loud too. It's crazy. Wolfie base.
Just use my Wolfie module.
No, we're doing it from scratch. But we could just use Solomon's cool Wolfie module to get this as well. And so we've got that image, and we're going to say with file. Whoa. All right. VS Code's fighting me a bit here. With file at bin greetings. And we'll put in the binary there. And so with that, we also want to expose the port that it runs on, which is 8080. Expose port 8080. And then we can say we want the container to execute a command, because right now it's just a container with our binary in it, but it doesn't know to run it, right? So we can say with exec, and this will be in greetings. So we just want to run our binary, and then we'll return this as a service to make VS Code happy. So to recap this little pipeline, we've called this earlier pipeline where we do our build. So now we've got a binary with a backend compiled, and now we get a new container with Wolfie. We put our binary in it. We say this is the port that this container should have exposed, and then we say execute the greetings binary and return that as a service. And so now let's say Dagger their backend module. So that module is at Dagger/backend. Call run with source as this directory, and that's going to be up. So once that's running, it has to build everything again for us. And I think that's, dependencies. There we go. So if I curl over here, localhost 80, we've got our greetings. But now we could even run the front end again. So if I said Dagger call Dagger front end module, call run, source is website, up ports E180. So this will run the pipeline from before. So now we've got like 2 Dagger sessions going on, each running some services. And if we go back here, then now our front end is happy because it's got that message from the back end displaying. But we'll take this one more step further because who wants to run 2 terminals, right? So we want the back end or the platform team to provide one function that runs our whole stack. Because, what if you've only got one terminal? So let's go back to our main.go, and I'm just going to say develop, basically to regenerate the code gen with our new functions that we've added. And we'll say we want a new one, func, and this will be run once again with source. And this will return a service. So same interface for all 3 modules, except this one is like the top level. And then we've got the separate teams maintaining their own parts of it. So I could say backend service is dag.backend dot run source, and maybe it didn't. Oh wait, backend. There we go. Okay, so now we've got this run function that gets our service for the backend, and same for the front end. Service dag dot front end dot run. And again, this is source dot the subdirectory website that we want the front end to have. Okay, so now we've got these two services. Now, how do I turn those two into one service to return? Well, maybe the Daggerverse has something super cool that can do that. And maybe it's called proxy. So there's this module that allows you to proxy any number of Dagger services through a single service. Sounds like something we need for this, and I trust this Penfound guy to write good modules. So we're going to copy that one, and we're going to say Dagger install github.com/kpenfound/Dagger modules/proxy at this release tag. And so if we look at this while that's installing, the API of this module is we can basically get this proxy object and call with service as many times as we want to add multiple services to this one proxy. And then in the end, we want to call service to get the actual underlying service that's proxying all these other services. So this might be a bit complicated, but we'll see once we put it together that it's literally just taking those two terminals that we ran before and putting them into one service that we can use from our machine. So we've got, I just want a new line. There we go. So if I say dag.proxy, so this is our new module. We're going to forwarding multiple services into a single service. So we can say with service. And so when we call with service, we pass in a Dagger service, the name of it, and then ports basically. And that could be more helpful if that Penfound guy added more descriptions to his functions. That's okay. We'll talk to him after this. And so we pass in both of our services back in our front end. Backend service, and this will be called backend, and the ports are 8080. And then let's say we also pass in our front end, so with service, front end service, and we'll call that front end. And let's do 8081 to 80, because again, I don't think I have permissions to forward to 80 on my machine without running a sudo. But who wants to do that anyway? And then from here, we can say service to get that service object. And so if you can use your imagination to think about all the things that this function's putting together, like we're going back and from this one spot, calling out to the front end and back end modules. And within this backend service, we're calling the backend run function, which calls the backend build function, which does stuff with like Golang image and all these things. And going back to the other branch of the DAG, we have the front end, which is calling the front end run, which calls the Hugo module that builds a container with Hugo and all the Hugo dependencies and all of those things as well, right? And we're just simplifying that to one thing where we can just call run and get our whole stack running just for that. So if I say Dagger functions, we'll see our run function here. And it's going to do some serious magic like we just described. And it'll totally work the first time. So run, again, that guy doesn't like
you have a typo,
writing descriptions.
the typo in the host name front end.
Oh, thanks. I don't think it actually does anything, but who knows? We can say
Oh, I thought that was
on
host
the
name.
whole stack. It is, but it's just like under the hood. For people that know the implementation details of the proxy module, it's just magic. But yeah, thanks for that. And if we run this again, we'll have our nice description. Because we had a sit down chat with Mr. K Penfound and said, write descriptions for your functions. So if we say Dagger call, our run dash source is this, and again, it returns a service, which we want to be up, then we're going to build out that massive DAG of all the things. We should have things happening concurrently and all over the place and stuff flying by our screen. And in a moment, we should see, Nginx and our binary running. So we have Nginx, and actually the proxy is running Nginx with reverse proxies to those other services and all those things. So kind of cool that we have all these things happening within the Dagger network. And
does it work?
Now it works, yeah. So we have our website, and we can see we also have air hordes, and we can see the traffic coming in over here. So yeah, with that, how long do we spend on that?
Nice.
Almost 45 minutes. We're able to build modules for our front end, back end, and platform teams to build and run our application. So from there, you could extend that and run your testing and linting and all those things. And if you have basically consistent interfaces for these modules that each team can expect a module to have a build function and a run function and a lint and a test, then you don't have to worry as much about how those projects are implementing that. You just know, oh, this run takes in the directory and I get back a service that actually runs it. And I don't have to worry about my tool chains or any of these things. It's just magically working. So yeah, that's that. Are there?
Yeah, Solomon, if you would like to add something on the community and collaboration part of Dagger as well.
Sure. Yeah. Well, the community is the starting point for us. We call our model community-led growth. So if there's one thing that we recommend doing, it's joining our Discord and saying hello if you're interested. Even if you're still looking for a use case, you're not sure where to start, I would just join the Discord and say hi and start from there. And then remember, baby steps are fine. The whole point of Dagger is you can play with it in a very simple way like we saw, and you can Daggerize your whole project all at once or a tiny little piece. It's up to you. Also, we have Daggernauts now starting to use Dagger in pipelines other than CI. We have data pipelines being Daggerized, AI pipelines, and we even have some projects using Dagger functions as LLM function calls. You can tell an LLM like OpenAI, et cetera, to do things, and it has an API for calling functions. It turns out you can give Dagger functions to the model to call, to interact with the world. So there's all sorts of fun things going on. If we had another 30 minutes, I would show you just random demos of crazy Dagger modules out there that do ridiculous things. But yeah, it's designed for productivity and also for fun. So yeah, come have fun with us.
Awesome. So I'll be putting all the links in the description of the video as well, and definitely join the Discord, which is there. The repository, Kyle has already committed the code, so you have the repo that you can try on your own and see how stuff works, how things are working. Rewatch the stuff again to understand what Dagger is, what problem it is trying to solve, and how you can start small and how you will be able to do your full pipeline. Thank you so much, everyone who tuned in for this particular session. But anyways, I think it's pretty cool. The demos worked really, really well, clean, smooth, and big round of applause for our stars, Solomon and Kyle. So thank you all for tuning in, and hope you enjoyed the workshop. Try it again. Tweet out what you learned, post on LinkedIn, tag Solomon, tag Kyle, tag Cube Simplify. Yeah, I always forget to plug the Cube Simplify channel. So make sure to subscribe to the Cube Simplify channel and share the stream with everyone in your network so that everyone can learn Dagger and get involved with the awesome community that Solomon is famous for building over the years. So thank you all, and see you next time.
Awesome.
Bye.
Thank you.